In section 8.5, you're really going to begin to see the power of compound interest in growing an investment. In section 8.5, we're going to study annuities, methods of savings, and investments. Basically, we're looking at how to save money over a long period of time, specifically for something such as retirement. Did you know that it is possible to save over $1 million in an annuity, even if you make less than 3 figures? If you set up an annuity early in your career, and you contribute to it regularly, then compound interest causes it to grow exponentially. So it is an honor and a privilege to be able to share this information with you so that you can consider setting up a retirement account as soon as you begin your career. So what is an annuity? An annuity is a sequence of equal payments made at equal time periods over a given term. So, for example, we talked previously about depositing $25 per month into a savings account every month for 25 years. That's an example of a long-term investment. The regular payments that we were making were $25 each. They were made every single month over a long period of time. Now, if you take that investment and you put it into a compound interest-bearing account, it becomes an annuity or a long-term fashion of saving money. The value of the account grows because you are contributing to that principal, making those equal payments. And at the same time, it is gaining compound interest. So it's a very powerful way to save money specifically over a long period of time for something like retirement. The value of an annuity is the sum of all deposits and interest earned over the term of the annuity. So the way an annuity grows is by the deposits that you make, and oftentimes employers will match your deposit into your annuity account if you have benefits, and that account is growing because of compound interest as well. So let's consider example 1 to get an understanding of how an annuity works. Suppose you deposit $2,000 at the end of each year for 3 years. Okay, notice it says here the end of each year. This simply makes it something called an ordinary annuity. There are ordinary annuities and something called an annuity due. In an ordinary annuity, the deposit is made at the end of each period. Okay, but we're just going to stay focused on ordinary annuities. So we're going to deposit $2,000 at the end of each year for 3 years. You could visualize this or imagine this. Let's say you get a Christmas bonus every year from your job, and you decide to deposit that into an annuity to save it and make it grow. And you're going to deposit this money at the end of the year for 3 years. The interest rate is 6% per year, compounded annually. So we're looking at once per year. Find the value of the annuity after 3 years and determine the interest earned. So we want to find the value of the annuity and the interest earned. Now, year 1 is easy. That's when we're just getting started. We've gone through the year. It's Christmas time. We get our Christmas bonus, and we take that Christmas bonus, $2,000, and we deposit it in this annuity. Okay? Now, for all of year 2, this $2,000 is gaining compound interest. Okay, so we're going to consider the value at the end of year 2 as a compound interest investment, right? We started with $2,000. The rate of interest was 6%. We're looking at annual compounding, and that occurred over 1 year, right? Now, that is our first deposit. So this $2,000 came from the deposit over our first year. But at the end of this year, we're also going to add another $2,000, right? Christmas time is here again. We're ready to add our second deposit. So at the end of year 2, Our first deposit will gain 1 year of compound interest, and then we will add to that with our second deposit. So let's see what our investment will grow to. So we have 2,000 times 1 plus r over n, exponent nt, that's just 1, and then I'm going to add my second deposit of $2,000. So the amount in the account at the end of year 2 is $4,120. This becomes the principal for year 3. So for year 3 now, we're going to take our $4,120 and we're going to treat it as a compound interest investment, 6% compounded once per year. And remember, we're calculating this year by year. And then we're going to add our third year deposit. So this calculation will take us to the final value in our account at the end of year 3. So 4,120. Remember, that is the first 2 initial deposits plus an entire year of interest, right? So now we're starting to earn interest on interest. And our third and final payment of $2,000, this investment grows to $63,6720. $63,6720. Okay, so this is the future value of our annuity. Now, the other question, how much does this cost us and how much interest was earned? Okay, so our contribution to this account comes from our 3 deposits, right? We deposited $2,000 per year, every year for 3 years. So our contribution was $6,000. But the future value is $63,6720. So the difference between those two gives us the interest earned. So the interest is going to be calculated as $63,6720 minus $6,000. So we can see that's $367.20. So this is an example of a short-term annuity, but let's suppose that this is a retirement annuity. Let's suppose you're going to be looking at a 30, 40-year investment. This is a very tedious calculation to have to do over and over and over every month for 40 years, right? So we're going to examine now, oh, sorry, I put that in the wrong place. Total interest earned, $367.20, okay? So we're going to examine next a formula that will zap this whole process together in one efficient formula, and that will be in the next section.